All right, 8.5, graphing rational equations, hyperbolas. So we're going to start with the easy ones, the basic ones today, and then tomorrow will be a little bit more advanced where we get into holes and all kinds of other things going on. So let's first review the parent functions. So, we started off with linear, and those are in the form y equals x, and we all kind of know what those are. And then we went into the quadratics. And quadratics are anything that's like y equals x squared. And we know that they look something like this. They're a parabola. If there's a negative sign, it flips down, that kind of stuff. And we had cubics, which would be y equals x to the third power. So they go up, they go down, and they finish back up. And then we kind of got into some variations of those. We had y equals x to the fourth, which is a quartic, which actually looks a lot like a quadratic, but it kind of comes down, then kind of might go up a little bit, and then go back up. So it's kind of like a W. And, maybe an x to the fifth power. Those look like x to the thirds, but they just kind of have an extra little squiggle in there that makes it do something like that. And you could shift them up, down, left, right, flip them over, all kinds of good stuff. Then we also had absolute value. So absolute value equations, those were like a V. So you had your axes, and then those kind of looked something like this. And they could flip up, they could flip down, they could go left, right, they could get skinnier, they could get fatter, all that type of good stuff. We also had, so remember those would be y equals absolute value of x. We also had the square root, so we had square root functions, which those ones are on a grid, and they kind of took off something like that. So y equals the square root of x. We also had exponentials. So we had something like, y equals 2 to the x, or, y equals e to the x. And those started slow and then ramped up. And then we also had logs, so we had y equals log of x, or y equals the natural log of x. And those ones kind of came down and flattened out like that. So we have all different types of these parent functions. And we're going to learn a new one today. So the parent rational function, that's the one we're going to focus on. So the rational parent function is f of x equals 1 over x, or if you want to think about it, y equals 1 over x. And these are called hyperbolas. All right? So not all rational functions are hyperbolas, but the ones that we're talking about where there's a number on the top and a variable on the bottom, these guys may have some asymptotes. So asymptotes were those lines that you can't cross. So let's kind of take a look at this thing. If I do a little table, we just kind of start off with like an x and y table. And I want to do y equals 1 over x. Well, let's pick some x values. Let's put it on a graph over here. So here's kind of going to be my grid. And we'll start at 0. Well, if x is 0, 1 over 0, we're not allowed to do that. So this is undefined when x equals 0. So that means that x can never be 0. So if I'm thinking about my domain, x cannot equal 0. But it really could be everything else. So it really could be all reals, except x is not allowed to be 0. So there's an asymptote right there. So there's this asymptote coming down that kind of blocks it from crossing over that line. Let's pick something else. Let's put let's put a 1 in there. Well, 1 over 1 would be 1. If I put a 2 in there, 1 over 2 is a half. If I put a 3 in there, 1 over 3 is a third. And if you kind of start gridding this thing out, just got to go a few spaces in each direction. So if I start plotting that, 1, 1, 2 is a half, 3 is a third, 4 is going to be a quarter. And it just starts getting closer and closer to 0 as you come down this way. But it's never going to cross. It's impossible for that to cross 0. It's just going to be a smaller fraction. If I put x as 1,000,000, it's 1/1,000,000th. But now if I actually put other fractions in here, and I'm like, well, what about, let's say if I put a half down there. 1 divided by a half is 2. So if I go over a half up 2, and the same thing is going to happen up here. So you have this line kind of coming down, and then it curves, and it's kind of trapped up there in quadrant 1. Right? Well, now if I put some negative numbers, I'm not going to go through the whole table again, but when you do negative numbers, the same type of thing is going to happen. If I put a -1 in the denominator, I get -1. So it cuts through here. And I'm also going to notice that this thing will never go positive. No matter what negative number I in there, it'll be trapped. It won't go positive. So it's going to kind of look like this. So we also have another asymptote right here. So we have two asymptotes. So let's first talk about the range. We talked about the domain. The range are the y values. Well, it looks like y could be anything. It goes positive infinity, negative infinity, but it can't be 0. So the domain and range for this one's pretty easy. Neither of them can be 0. All reals except that. Well, let's look at the asymptotes. So we have a vertical asymptote at x equals 0. And in the future, on other problems, I'm just going to call this VA, vertical asymptote. And we have a horizontal asymptote, if I could spell it correctly, horizontal. A horizontal asymptote, which I'm going to just call HA in the future. And that's going to be at y equals 0 for this one. So we have these two kind of boundary lines where we're trapped. So that right there is the parent function. It's called a hyperbola. A lot of applications with sound and other things, as you get further into stuff. But now we want to look at the transformations. Like, how do you move this thing left, right, up, down, stretch it, shrink it? So that's kind of what the focus of today is going to be. So let's scroll down and let's explore some of these other graphs. And instead of me just kind of telling you this, I kind of want to graph this on Desmos. So I'm going to come over here and I'm going to pull up Desmos really quick. And let's just type in the parent function. So y equals 1 divided by x. And that's the one that we just graphed right there. And I'm going to now, on our notes, we wanted to look at, well, what about when it's 1 over x minus 3? Like, what happens when I do that? So if I plug in y equals 1 divided by x minus 3, if you notice, if I get rid of the first one, it looks like this thing just shifted to the right. This was the original. And now when I do the x minus 3, it's the same thing. It just shifted over to the right 3 units. So that kind of gives us one of our first rules. And it basically says that if you have a number down here affecting x, it's kind of like it was with quadratics. It's the opposite of what you would think. So when the x is being affected by a minus 3, that means it's going to move to the right 3 units. So sketching a graph of that, I'm like, all right, it's no big deal. Sketch a quick little graph. Well, the asymptote down here didn't change. It didn't really move up and down. So I still have this asymptote at y equals 0. But now the vertical asymptote is going to come over here and it's going to shift down. And we just need a sketch. We don't need it perfect. So it's going to kind of do something like that. And then something like that. All right. Now, if I really wanted to get into it, I could find that y-intercept. You know, if I said, hey, let's figure out the y-intercept, because maybe I want that point to be somewhat exact. Well, for a y-intercept, that means that x is going to be 0. So if we let x equal 0, we're going to have y equals 1 over 0 minus 3. So I'm just putting 0 in. And that ends up being, what, negative 1/3? So if I did want to be exact, maybe I call this 1. I could say, well, hey, negative 1/3, is right there. So I got the intercept. There's not going to be an x-intercept because there's an asymptote there. It doesn't cross it. But sometimes we are interested in what the intercepts are. So we've sketched the graph. We described the transformation. And all we really need to say is it went right by 3 units. All right, let's run down, try a couple more examples here. So I notice on this one, it's a little bit different in the fact that the x is not being affected, but this back number is being affected. So let's kind of go back to Desmos and let's kind of take a peek at what's going on when I put that one in. So instead of affecting the bottom here, right now they're on top of each other. But if I do a -2 and I get rid of that, it looks like the same thing. It just moved down by 2 spaces. So this was the original. And then here comes the new one. It just kind of shifts down by 2 spaces. So moral of the story is when you're doing a number at the back side, that backside number is going to control up or down. And it kind of does what you think. So since it's -2, this one is going to shift down 2 units. So, in my mind, I'm kind of like, all right, I know what the parent function looks like. I'm going to draw it really light here. The parent function does like, whoop, I was in the wrong quadrant. Sorry about that. So the parent function, the original, the OG, does that and does that. And now all we want to do is just shift that down, excuse me, 2 units. So I didn't move left or right, so I need to keep this asymptote right here. So this asymptote stays the same, at x equals 0. So I have a vertical asymptote at x equals 0. And my horizontal asymptote used to be at x equals 0, but if I'm going to shift it down 2 spaces, it's now, I have this line that I can't cross down here. So the horizontal asymptote is going to be at y equals -2. And now I'm trapped in a little bit different place. My new function now is going to go right there. And it'll come down, down, down. So it still is that same smooth curve, just where it's trapped is kind of in a different place now. All right. So more of the story is the back number shifts it up or down, and it does exactly what you would think that it does. All right. Let's go over here to the next one. And I guess I can leave that up there. Well, this is a combo. This kind of has 2 things going on. So when I describe the transformation, that +2, I would think that's going to move it to the right, but it's actually going to move it left 2 units. And then this is going to move it down 3 units. So there's my grid. And I want to put these asymptotes in. So normally, if we're going left 2, that means I got to go over here 1, 2, and then if I'm going to go down 3, I'm going to need over here a little bit. So now let's kind of trap this. So I have an asymptote right there. I have an asymptote right there. And now I kind of want to look at where that crosses, and I should be able to go in here and put my line. And it looks like we're going to be, and if I wanted to get kind of exact, like instead of just kind of coming down over in this area. If I wanted to get kind of exact, I could find an intercept for the x and y axis. So maybe let's just do that. So I know that for the y-intercept, I want to let x equal 0. So if I let x equal 0, that's going to be 1/2 take away 3. Well, that's negative 2.5. So right now I know that my y-intercept is at negative 2.5, which would be right there. And if I wanted to go in here, I wanted to find my x-intercept. Well, x-intercept, you let y equal 0. So I'm going to solve this thing, and I'm going to be like, well, if y equals 0, that 0 equals 1 over x plus 2 minus 3. And add 3 to both sides. Multiply both sides by x plus 2. I'm going to jump up here. That would be 3x plus 6 equals 1. Because remember what I did was I multiplied this side by x plus 2. And I multiplied this side by x plus 2. These will cancel. And then I have to distribute. So that's kind of where that came from. And that would be 3x negative 5. And that would be negative 5/3. So I have an x-intercept of negative 5/3, which is negative 1 1/3. Or negative 1 2/3. So there's my lines getting a little bit tighter to where they're supposed to be. Something like that. If I need to. If the question asks me for that. All right, so this little chart here is going to kind of summarize what we've been doing. We didn't really talk about the A part. I think a couple of them come up in our homework. But the big deal is when you know there's a number up on top and the x is on the bottom, you know it's going to be a hyperbola. And there's always going to be the vertical asymptote at this line down here. It's basically whatever makes the bottom 0. So the vertical asymptote is that x equals h, but it has to be in this minus form. So that's why when I talk about it, it's the opposite of what you would think. That's what's going on. So the bottom is the vertical asymptote. And over here, that's the horizontal asymptote. So when you're talking about hyperbolas, that's where you kind of get those two numbers. I always kind of think of it as the undefined, like, you know, hey, x is undefined when it's a certain number, and that'll give me my asymptote line. All right, so it says identify the asymptotes, the domain, the range, and then we also have to find the intercepts. We don't really have to graph these if we don't want to. I may decide I want to just to make it like a little bit more visual, but we'll kind of fly through these kind of quick. So thinking about the asymptotes, well, the vertical asymptote is when x equals 2, because that would give me a 0. That would give me an undefined on the bottom. So I know x can't be equal to 2. So I know there's an asymptote there. The horizontal asymptote is going to be at y equals 4. You know, maybe I want to just quickly sketch this because I'm like, well, the normal parent function, it moves right to, which is going to put me a line right here. Although it's supposed to be an asymptote. So my little dash button didn't work too good there. There should be an asymptote. Come on. The button must be getting wore out on this thing. If it doesn't do it this time, I'm going to move on. There we go. And then if we move it up 4, then that means 1, 2, 3, 4. We should go straight across there. Sweet. So I have my horizontal, I have my vertical. What else do we need to do? Domain and range. So the domain and range. So the domain are what x values are allowed. Well, everything's going to be allowed except for we're not going to be able to be x equals 2. So x cannot be 2. But it's really all the other x's. If you really want to get fancy, you'd say it's all x's such that x is not equal, all reals except for x is not equal to 2. But I don't really need you to get that fancy. And for the range, all reals, but y cannot be equal to +4. So we've knocked out asymptotes, domain, range. Now we need to find the intercepts. So to find the x-intercept, so let's get the x-intercept. That means y is going to be 0, so we got to solve this. So we solve that equation. I move 4 to the other side. So let's kind of get rid of this stuff. So I got enough room. If I move the 4 to the other side, I get that. Multiply both sides by x minus 2. And I get 4x minus 8 equals 1. Add 8 to both sides. Divide, divide. So that's what, about 2 1/4. So my x-intercept crosses at 2 1/4. Did I feel like something didn't go quite right there because that doesn't really match up with my asymptotes. So I put 0 in for y. Move the -4 over. -2, -2. Oh, there should be a +8. That should be a -4x and a +8. So that's why we always visually check to see if it worked. -7, divide, divide. I got -7/4. So that's like -1 3/4. And that looks a little bit better. So -1 3/4 is that guy. Then my y-intercept, where's that one going to be? So y-intercept is let x equal 0. So that would be 1 over y equals 1 over -2 added to 4. So -1/2 plus 4, that's 3 1/2. So my y-intercept is at 3 1/2. That x-intercept still does not look right to me. Right 2, up 4. So let's just look at that x-intercept one more time. See what I did wrong. -4 from both sides. Multiply both sides by x minus 2. It's going to be -4x plus 8 equals 1. I see what I did. I lost the negative. So it's 1 3/4. Trying to go too fast. So +1 3/4. That looks better. Because I knew this thing was going to go around. Kind of hug down here. I'm not really caring about these points up there. As long as you know the shape of it, we're good to go. So, got everything answered. Let's bump over here to the last one. See what we can do here. So just looking at the transformation, it looks like we need to go right 3 and then down 5. So right 3, down 5. So right 3, down 5. Those are my two asymptotes there. So down 5. So I have a vertical asymptote at x equals 3. I have a horizontal asymptote at y equals -5, which matches up with what the little table up above said. And I know, I know what the sketch is going to roughly look like, but let's go ahead and get our intercepts just so we have them. So for the x-intercept, that means we got to let y equal 0. So let y equal 0. Add 5 to both sides. multiply both sides by x minus 3. 5x minus 15 equals 1. 5x equals 16. So that would be divide by 5, divide by 5. 3 1/5, or 3.2. So my x-intercept is just past 3, 3.2. And I know it's going to kind of come down. It's going to go that way. So that's that critical point. The y-intercept. So for the y-intercept, I let x equal 0. So for the y-intercept, let x equal 0. And that's negative 1/3 subtract 5, which is negative 5 1/3. So there's my y-intercept. Negative 5 1/3, which would be way down here, which makes sense because this thing's going to be flying in and then head down like that. All right, then we jump into the practice. So hopefully you got enough there to, to answer these questions. One thing I didn't do is the domain and range for that one. So if you kind of want to go in, you want to fill that out. Basically, the domain and ranges, it just can't be the intercepts or the asymptotes. So the domain, x cannot be 3, but it can be everything else. So all reals except x can't be 3. The range, all reals, but y can never be equal to negative 5. So there I answered the domain and range part as well. All right, hopefully this helps you out for the practice. Shoot.